Hey everybody, and welcome back to the Kodiak Shack podcast. Today we have Steele from ResCon, and he's had quite a storied past. He's been flew the F-15C model, which I'm getting ready to do. He flew the F-16 for a little while, and then when his guard unit transitioned to MQs, so MQ-1s and 9s. And now a word from our sponsor. Crowdbotics Defense is a data analytics software company serving the United States Air Force. They make it easy for active duty servicemen and women to turn their ideas into products and tag team DoD adoption. If you or someone you know has an idea for how tech can speed up your team, increase efficiency, or make your life easier, reach out to Crowdbotics Defense to talk it through. Crowdbotics Defense will help you define your project scope, timeline, and cost, and work with you to secure the budget you need to build it. Any product built and adopted by DoD will be credited to you as the collaborator. Reach out to Julian at crowdbotics.com for help. That's Julian, Julian, at crowdbotics, crowdbotics.com. Also, there will be a link in the show notes. Everybody I talk to in the DoD sees inefficiencies that could be streamlined or rectified with the hard work of software engineers and people in the United States Air Force. So work with Crowdbotics Defense to make a product that you are proud of and you're happy to work with. He was able to start flying those and then even went to weapons school there. After he did all that, he transitioned over to the innovation side, and that's what we're going to focus on. But Brian, thanks for being here today. And go ahead and tell us about yourself. It's not a trap.
Yeah, right. I know what the standard response for that is. Yeah, thanks for the intro, man. It was a great ride in the Air Force, 23 years. Got to do some fighter flying. I was a FAPE actually, first off, so did the pilot training thing in Columbus, Mississippi. So the first 4.5 years of my career was in central Mississippi there. Then fighters, and then eventually the last half of my career was MQ, like you said, and then just like everyone, I had to grow up at some point, so kind of transitioned to a leadership staff track after weapons school. So I went to Germany for my last kind of hurrah. I was part of the Guard and kind of augmented A3 staff at Ramstein. So while I was there, I was working on the MQ-9 contractor operation that was flying out of Poland at the time. It was pretty new, so kind of took that over. Had a lot of great lessons out of that, which we can talk about because that is kind of the transition that I had out of the Air Force, into the innovation world and into the business world. So being on staff and having a project with its own budget that I had to kind of manage and then fight for. It was a big budget that constantly ballooned because it was a contractor operation. So having to make a logical, cogent argument to sometimes to 1-star, 3-star, 4-star generals, like, hey sir, I know this already costs a ton of money, but we need to do X, Y, Z, and we need more money. Little did I know that would set me up for startup life pretty well. So yeah.
How was that with the? So you're kind of having these conversations. Obviously, you're the person who has the expertise in the area that says, "Hey, I know we spent money. We need to spend more money." How does that conversation kind of go? And then how often is that happening? Are we finding that we're putting more and more money behind programs that we already have?
Yeah, I mean, that's a loaded question, multi-layer question. So I guess the first part that comes to mind, is rolling into that space with both an operator mentality and a kind of a higher level leadership kind of strategic mentality, right? So when you present something to your boss, you have to be able to look at it from their perspective too, right? So when that is the 4-star USAFE commander, like I can't possibly put myself in that guy's shoes, right? At that time it was General Haragian Cobra, so I did kind of know him. I crossed paths with him at Tyndall when I was in the F-15. but anyway, I couldn't get into that kind of headspace, but just trying to look at everything from a strategic standpoint, like this is why you want to spend this money, boss, and not just an operator standpoint or a SME standpoint, is a huge challenge. Yeah, and I don't know if you've ever been involved in a large budget program like that, where part of you as a red-blooded taxpayer, you're kind of like cringing, like, man, this is already really expensive, and I'm asking for more. But you get over that pretty quick because you're advocating for an effort that you know is worthwhile. You can get passionate about it. So, yeah, part of me knew it was kind of a ridiculous ask when I went and did that, but I actually believed that the capabilities were really important. And let's back up a minute. What were we doing? We were laying the foundation for RPA operations, so remotely piloted aircraft operations in Eastern Europe. It turned out, a year and a half, 2 years later, that a lot of stuff went down in that area, and that it became pretty important. So in the end, it kind of all made sense and all came together. So anyway, backing up to your question, yeah, what is that like? It's definitely a challenge, but believing in what you're talking about, trying to look at it from all those different angles, from the practical angles to the more long-term strategic angles, and then selling that so that your boss has the notion that he can't say no.
And I feel like they probably have those meetings all the time. It's just like one person after the other is saying, I need money, I need money, I need money. And they are the one who the buck stops there, right? So they have to make that decision. So you can't really fault them because they've got to triage what actually needs to be done, which is for what's nice to have. I would assume. I mean, correct me if I'm wrong.
Yeah, I can't imagine that responsibility. That's another great point. Is what may seem like more money than I've ever dealt with in my life is a drop in the bucket to those guys. And it sounds cliche, but there were a lot of bright shiny objects that they had to deal with. F-35, F-22 movements, rightfully so, those got a lot of their attention in the theater. So those fifth gen objects. So the little MQ-9 contractor operation, despite its price tag, was pretty much an afterthought. So we use that to our advantage as well, right? Like pretty big impact for a relatively small footprint, and we try to leverage that as much as we could.
I think one thing that people probably don't realize who haven't kind of been exposed to the MQ-9 side is there's a lot of infrastructure. It's not, hey, we're going to fly MQ-9s out of here. Just like you bring a fighter out, they just land. And as long as there's liquid oxygen, nitrogen for the tires, and fuel, they can operate. But an MQ-9, there's so much more infrastructure that probably has to happen at the base, and then all surrounding areas, and then probably some operating not so much, I guess, agreements, but also because it's not a VFR or IFR, right? So visual flight rules or instrument flight rules. So it's this weird in between where you can't just take off and fly across Europe. So I assume were those some of the hurdles and roadblocks you guys were trying to break through?
Yeah, absolutely. But again, we leveraged them to our advantage because those things weren't figured out, and we used the contractor operation to kind of pave the way for Big Blue to eventually move in. That really was one of the kind of underlying, baseline premises of what we were doing, besides the intel that the airplanes generated, which was awesome. It was just this forcing function of, hey, if we figure this out in Poland, it's a win for our relationship with Poland. We can lift them up and say, you guys have figured out how to incorporate unmanned aircraft into your airspace. You are actually ahead of the FAA in that regard, and you're definitely leading Europe. So it's a huge win for them. And then we use that to springboard to the neighboring countries, and eventually had airspace agreements with, like, by the time I left, it was like 14 different countries. So yes, it is not easy to move an MQ-9 around. you know the term ACE, right? So Agile Combat Employment is
Yeah.
loosely used with the MQ9. They're getting much better at it over the years, and because they have to be. But yes, it is a monumental effort, and yeah, we were able to throw money at the problem with the contractor to kind of avoid some of the the regulations and bureaucracy of a full Air Force operation. So we could kind of sidestep those, just pay money to say, hey, figure out how to live and how to eat. We'll help you with that, but basically that's on the contract, and then we'll use you to figure out all those other things that really helped out when Big Blue moved in, which they did because CENTCOM was winding down their operations, and lo and behold, UCOM heated up.
Yeah. What were some kind of parallels or some things that you learned while working with A3 and A5, and then now that you're in the innovation space, what did you learn, and how are you kind of using that to help you today?
Yeah, it's kind of crazy how it all came together. The big thing that stuck out to me from an innovation standpoint was, again, we were trying to, sidestep's not the right word. That has a negative connotation. We were trying to leverage the contractor operation to the max extent. So one way to do that, one piece that we could possibly leverage is the innovation space. So the process to put a new widget on an airplane, as you well know, is for right, wrong, or indifferent, but for very good reasons, right? It's difficult in the Air Force you can't just strap something new onto an F-16 and go fly, or an F-35. Yeah. And certainly MQ-9 is no different, maybe even more painful because of, like you said, all the infrastructure and all the networks and things that are touched by a new piece of software or hardware. But if it's a contractor operation, there's a little more flexibility there. So, you can potentially say, hey, as a service, can you provide this new type of sensor? Or, this is the requirement. We need to sense this. And maybe the contractor solution to that is a sensor that's not necessarily fielded in the Air Force, but it's a win-win because, they can get visibility now for this new capability. So as an example, there's a lot of interest in what happens to the MQ-9 if the data link is interfered with or severed, right? So I have to be careful with what we talk about, obviously, but I don't think I'm saying anything controversial there, right? So if you're flying the airplane via data link and you're downloading the intelligence from the airplane via data link, it's bad if that data link goes away.
Yeah.
That's not earth-shattering.
It's understandable.
Yeah.
Yeah.
So, okay, so this is the translation into the civilian world, into the quote-unquote real world, right? So in the real world, you have cloud and you have edge, right? So you have edge systems, like your phone or your self-driving car is an edge system where you don't want that car to rely on its 5G network connection to figure out its path down the road, right? You need that to be computed in real time. Just the latency and the possibility that link could be severed is no good, especially, it would happen at the worst time. You would drop signal right when, grandma pushing the baby carriage across the street and it has to figure itself out. That's the last time, the last place you want to be relying on your cell phone connection. So that has to be done locally on the device, which is called edge computing, right? So there's a huge world out there where not just military, but everyone can benefit from edge computing. And oh, by the way, as devices become more and more powerful, there's more and more data being generated. Like our networks and the bandwidth is just completely saturated. So we need devices to be smart so that they're sending not the raw data back to be processed, but like decisions, like, bytes instead of megabytes. So in the case of the MQ-9, you've got an HD 4K sensor that's sending full motion video back. So, it's megabytes and megabytes of data over a satellite link. That's a ton of bandwidth that's susceptible to, jamming, both intentional and unintentional. So, if you can have that thing process the video on board and make decisions off of that. A decision can simply be, I have found an SA8, I have found a T72. But it's making that decision on board, and then it's just reporting the fact that I found this thing at this location, which is just one line of code as opposed to 4K video. So that 4K video, in the normal world, gets sent back all the way across the world, and then some poor person, in a windowless room stares at it for hours and hours on end to say that's a T72. It's a huge just waste of bandwidth and resources and manpower, and I feel bad for that person. If the machine, if the edge thing itself can say, oh, that's a T72, which sounds easy enough, right?
Yeah. Well, and I assume there's some constraints that come along with that. So to put that edge computing on the machine, that requires more than currently exists, right? Because there's no edge computing now, like say an MQ-9, at least the host aircraft. So then how does that look? If you want edge computing, you want this kind of AI processing, what does that look like? How do things have to change to house it under today's tech, I guess?
Yeah, that's a key question, and it has two answers. So how do you improve the edge computing capability of a device? Most people immediately jump to hardware, but it is a two-pronged solution. It's hardware and software. So obviously software is where I come in, where ResCon comes in. So it's a great segue to what we're up to. So yeah, most people think, I need to do auto target recognition, on my drone, or on my, so when I say drone, let's kind of switch gears to an army dude that's like pinned down by small arms fire, and he wants to pull this little quadcopter out of his backpack and send it out to figure out where the shots are coming from, right? And he wants that thing to be autonomous. Maybe it has some sort of microphone system on it where it can sense the shots and kind of home in on it, and then it can auto recognize a firearm and kind of correlate with other intel and say, dude, that's the bad guy, he's right there. So most people think, okay, if I want to make that happen on a little quadcopter, the quadcopter is a great kind of example of an edge device, right? So it's power limited, it's small, it runs on batteries. So if you got a huge computer running on there, it's going to run out of batteries and not be able to fly very long. So it's kind of a great kind of optimization edge system to consider. And we want to do a lot of things with quadcopters. So if you want that thing to be smart, most people think, well, I need to get like the latest generation of GPU, like an NVIDIA, Jetson processor. I need to somehow integrate that in so I can now do these advanced AI ML processes. Part of that's true, but what if you could accomplish those same things, but through software, accomplish that on legacy hardware? So, right, where we think about kind of our standard algorithms that we use, machine learning, deep learning type algorithms that they do take a lot of computing power, especially to train. And then once they're trained, you deploy them to your edge device. They're pretty hefty models to evaluate in real time, so they take a lot of computing power. So if you were able to have a better math, better model, you could potentially evaluate that model on kind of legacy hardware that's already there. Or take it a step further, you could have software that's so powerful or so low power and kind of revolutionary that you could have multiple instances of it and actually clean up and reduce the power consumption of your current processes. So that's kind of where we're headed.
Well, I think those are kind of, makes me think of two things. One thing, I just posted about it on my LinkedIn account, which was the F-22 Raptor just flew with third-party software on it, which is a huge game changer because so often are jets specifically hindered by their ability to get a new operating system. So the F-16 calls an OFP. So think of your iOS for your iPhone, and your operating system is going to control what your software or your hardware can do. Well, jets only move as fast as their software updates. But now we're talking, we don't need new hardware. We just get this software update that can be a game changer and now create processing and computing, or thinking or learning or assessments that wasn't able to be done on the same hardware yesterday. And that is a big change, because you think now we have, I don't know, thousands of fighters that can go in for a software update and have a massive tactical advantage now that is not accessible, because you think everything runs on Intel assessments, like, oh, so many aircraft went into the depot level maintenance to get ripped apart and new parts went in. But now it's, hey, some guy who always plugs into a jet, but then that jet is now different than yesterday. And that's a huge change, because when you're thinking tactically and strategic and operationally, like, that is a big problem for an enemy, whether it's us looking at our adversaries or our adversaries looking at us, which I think that's huge. And then when you talk about, it's not a massive multi-million-dollar airplane, it's something very small that can't have all the hardware needed for it. Now it's just a small amount of hardware, not needing all that juice to run to get that benefit of like a big clunky kind of AI machine on the edge device. Am I understanding that correctly?
Yeah, and I love that story too. I saw that come through LinkedIn, and that the MQ-9 was kind of ripe for that kind of treatment as well, and something that was posited. I don't know whatever happened to that effort. I think the Guard kind of got pretty far along with basically creating a, for lack of a better term, a DMZ in the ground control station, where basically you could run any, within reason, you could run software in there, third-party software, and you didn't have to accredit and get an ATO for every single thing that came through, because it was operating within this demilitarized zone that was kind of specially designed to take on third-party apps. So the fact that the F-22 did it is amazing. I love the idea of, you tailor the jet for the day, for the mission, and then, like, dude, I don't need this air-to-air app today, or I don't need this air-to-ground app today. I need to upload this specialty app that's specific to this mission, and off you go. Right, so you don't have to have like unnecessary things kind of like bogging down the OS. Yeah, that's a really cool thing, and yeah, I think you understand it pretty well. So increasing edge computing is not all about hardware; it's also about software. So, and the hardware manufacturers recognize that, because there's a physics limit, right, to processors and chip design, just the fundamental physical limits of how we make these things, until we shift over to quantum, which it's going to be quite a while before those things are a reality, and then shrinking those down to practical size, etc. So yeah, we're basically, if you're familiar with Moore's law, right? So faster, cheaper, better. About every year you have that. Yeah, that runs into physics pretty quick. It already has started to. So even the hardware manufacturers are looking for new ways to approach problems and new math, right? So, because that's all it is in the end. It's just math. It's just software. It's just new ways to tackle these problems, where deep learning has done amazing things and really kind of grabbed the spotlight when it came around. I want to say like 30, 40 years ago when it started, and really has a lot of momentum and a lot of money behind it for research. And it is great for kind of these large models for like natural language processing. So Siri and Alexa, no worky without like the cloud connection and that big model running on those computing resources in the cloud. But amazing capability there. And then, auto target recognition, same thing. So to be able to have kind of like a generalized software that can recognize multiple different things, that's going to be a big model. What we're starting to chip away at is machine learning processes that are specific to time series data. And we're deep learning will work, but it's way overkill. So much so that we've shown that we can do as well or better, with like 1 million times less power or less data, or 1 million times faster training times. So I can give you some specific examples as we get into it.
Well, actually, before we get before we get into that, we kind of got ahead of ourselves. So ResCon, what do you guys? You obviously started the company. So how did that start? And then obviously we can expand on what we're talking about now, on what you guys are working on, just so we give the whole picture.
Yeah. Well, how it started is a pretty cool story that I want to share, kind of, as its own vein, because if anyone's listening to your podcast and is kind of in the same boat that I was, the pathway that I found to like owning a business, I had no idea it existed, and I think there's a lot still to know about it, to kind of learn and to facilitate about it. So the way ResCon kind of came about was, well, number one, it was dumb luck, which I hate the fact that that's true. I hate the fact that there isn't some sort of organized, funneling system for people like me to be paired with people like my co-founders. So let me explain what I mean by that. When I was in Germany on staff, one of the big brain dudes on staff that kind of helped me along with the MQ9 project, he knew a guy who worked at DIU, which I'm sure you're familiar with, right? Or worked with DIU on the civilian side. So Defense Innovation Unit out in Silicon Valley. So this is an entrepreneur who had touched some DoD organizations and was somewhat savvy about what DoD was into. So he was hired. This gentleman was hired by Ohio State, which is was my hometown at the time, Columbus. I was in the Ohio Air National Guard. So it just so happened that this dude knew a dude who was hired by my hometown big university, and this gentleman had kind of taken upon himself to look at all the IP, the intellectual property portfolio that this university had, and he kind of handpicked the things that he thought could be dual use, right? So DoD would be interested in, but also had a commercial kind of tech future. So that was a really smart thing for him to do. Like, I wish there's more people doing that, right? And then the fact that I just got introduced to him randomly. So me being someone that, I was coming up on 23 years in, I knew I was going to get out. I didn't want to be an airline pilot. I wanted to try my hand at business. I really wanted to own my own business, and I didn't want to franchise. I wanted to do a startup, but I'm not an inventor. I can tinker around and I can build a drone for you, but I can't, I don't have the PhD in computer science to come up with something. And then, I had this kind of insider knowledge of what's going on with unmanned aircraft and kind of the intel processes around there. I know where some DoD pain points are. So to pair someone like me with someone like the gentleman at OSU named Ray, I wish there was a mechanism out there to do that, because it was a really good match. So, Ray said, when I was introduced, Ray said, "Here's this IP. It's all about edge computing, machine learning, advanced encryption," which we can get into on a different podcast. He's like, "Do you think you could make a business out of this?" And I'm like, "Oh my, yeah, absolutely! This is what I work on every day. This is what we talk about at our desks in the vault every day. Is this exact thing? And what you're proposing does it way better than what we're trying to do, right?"
Yeah.
So I had to create a pitch deck, basically, to pitch my business, and I entered into kind of a blind competition for that IP, which I was selected to, in the end I was selected to have the privilege of receive the license for the IP. So what does that mean? The email, which I should print out and frame, says, you have been selected. Congratulations. And then it says, at the bottom, this does not come with compensation. In fact, it's the opposite, right? Like, not only do you have to figure out how to pay yourself, there's a lot of expenses involved with starting a business. So yeah, it's definitely not all ice cream and puppy dogs and rainbows. It is it's challenging, and we can get into like how we figure that out to this point. But that's how it came about. So a gentleman that got hired by Ohio State that just so happened to have this DIU DoD knowledge background that assembled IP that he thought was interesting, and then me coming, like, wanting to be a part of this community and start a business, and it was a really good match.
Well, I feel a lot of people leaving the DoD, at least on the pilot side, don't even think about the innovation space, about the startup world, because I think a lot of, my business partner and me and a lot of the pilots like yourself are all like, well, I'm going to separate and go to the airlines, and you know what I mean? And it's not a bad life. It's not a bad gig. It's just different people want different things. So I think it's good that you kind of struck out and tried to go find a different path, and it seems like it's working out. So we kind of talked a little bit about the product, the edge computing and everything. But can you kind of give a little bit of the intro, that kind of big picture, what edge computing is attempting to do that we haven't covered, unless we've already covered it?
Yeah. So let me just tell you like what our angle on it is. So I mentioned Ray, who worked for the Technology Commercialization Office at Ohio State, which, all major universities have these offices. There's professors that create inventions all the time, and they're professors. They don't either have the interest or the time, or the business savvy to do the monumentally challenging thing of like taking a bar napkin idea and making a product out of it. It's actually pretty hard, so I get it. So yeah, these technology commercialization offices are all over the place, and actually the government labs have similar offices as well. So there's a ton of IP out there. I don't know if you knew that. There's just a ton of incredible inventions, like game-changing, world-changing inventions, more than you can imagine, and it's just sitting there because no one has the time or the opportunity to try to commercialize it. Anyway, so I just so happened to find a small chunk of that, and so then so what are we going to go do? So my co-founder is not Ray, is actually the inventor himself. So the professor at Ohio State, his name is Dan. So he's a 30+ year professor. He was the chair of the physics department at Duke before he came to OSU. Yeah, he's a super big brain. His PhD's in optics, and then I think a lot of his research has been in quantum optics, but he's also gotten himself involved in this edge machine learning technique that he's refined over the years. So where's the common thread there? Dan is really a minimalist, so he's challenged himself his whole career to figure out like what the minimum is to do something. So quantum information theory is like encoding information on a single photon and like transmitting information. Yeah, so can't get much more minimum than that. And then on the machine learning side, he's been working on this technique called reservoir computing. So ResCon comes from reservoir computing or reservoir control, because reservoir computing is particularly well suited for controlling complex systems. But reservoir computing is a form of machine learning. It's actually an artificial neural network, a recurrent neural network that it's super low power and low data, and can do, like I said, it can do as well or better than kind of your state-of-the-art deep learning algorithms. It just takes a lot less data and power to get there. So I can give you some examples. and dig into more specifics of exactly that. But before I do, like, dude, so if anyone out there is like, wow, bar napkin and college professor, and then we have a company, there's a lot more to it than that. And so I had to figure out this whole SBIR, STTR world, and I know you've talked about that here before, and so I don't know if we need to get basically into an introduction of what that is, but there's a ton of government money out there. Well, hopefully it gets passed because it's up for renewal and it's being blocked right now. But hopefully it continues because it's been wonderful for our company and for a lot of others. But this is money that the government has to sponsor research into subject areas that they care about, and edge computing and machine learning certainly is like new novel methods of data fusion and data analysis is definitely something that they care about. So we had early success both in the state of Ohio. So, you know, whatever state you go to, they're going to have small business, you know, kind of incubator funds. They're going to have small business, you know, basically, you know, they're injecting funds into the economy for people like you and people like me to make businesses and to make cool things happen within their state. Ohio's done a great job with it. They have tons of programs. We've taken advantage of a couple of them. There's lots of organizations in Ohio that are meant to pair with businesses like ours to kind of shepherd us through the process. So we're paired with a company called Rev1 Ventures. Rev1 is in Columbus, so they're closely tied to Ohio State. There is a ton of innovation coming out of Ohio State, especially in like the medical space. And then Rev1 gets money from the state of Ohio and they get to manage it through grants and through kind of salary reimbursement programs. So we've hired interns over the years, and you know, we get like half their salary back through Rev1 because they manage a state of Ohio program to do that. So anyway, it's that's been a big help. But what really got us going was these SBIR, STTR contracts that we've won. So we've won 5 so far. We've completed 2, and we have 3 that are ongoing. They all kind of just started this summer. Our first phase 2, so phase 1 is typically like $150K for 6 to 9 months. Phase 2 is $750 for 12 to 15 months. So in order to get to a phase 2, you have to have done a phase 1. So it's a pretty big milestone for ResCon that we got into a phase 2, and we were actually selected last year for another phase 2, but it wasn't funded under the Agility Prime programs. I don't know if you've heard of Agility Prime, but that was our very first phase 1 was through Agility Prime, which was an AFWERX kind of sprint to look at the urban air mobility or advanced air mobility space. If you know what that is, that's like oversized drones that can carry people, like air taxis.
Oh, yeah. Wow. Oh, I have seen those. Yeah.
Yeah. So a lot of the tech in the small UAS drone space applies to these larger ones. Go ahead. What were you gonna say?
Oh, I was going to say, yeah, I've seen them. They were talking about how it was going to carry security forces around the base to go check, if there was an issue, rather than driving around, they would fly those across. So when for your, the unfunded, selected but unfunded is such an unfortunate thing. I mean, I appreciate that they select it, but you're like, yeah, but there's no money behind it. And the problem is the base doesn't have $750,000 to be like, oh yeah, we got this. Like that cash doesn't exist. So selected and unfunded is effectively not selected. You have to get in the right room quickly to get money out. Because if you don't, odds are that thing's not going to go anywhere. So what did you guys get selected for the phase 2 that you guys are, one of the phase 2s that you're working on right now?
Yeah. So
like what product were you producing?
Our sponsor is the Lifecycle Management Center Propulsion Directorate. So you mentioned a base. That is a potential sponsor. Like your end user could be a base, or your end user could be a weapon system. It could be the F-35 program office. So in our case, it's not the program office. So Lifecycle Management Center, AFL, LCMC, also has the program offices under it, right? But it also has these more generalized directorates. So the propulsion directorate is working with industry for the kind of producing the next generation of engines and propulsion systems. So our sponsor, our technical kind of point of contact, our manager for our project is actually the software lead for adaptive controls for propulsion. So the fact that we found this person is like the perfect person for us, right? Because we had pitched in phase 1 that we could create an adaptive controller for a small jet engine. So something called a micro turbine. So these are really interesting little things for several reasons. Cruise missiles use them, right? So it's a jet engine, so it has to be somewhat hefty, but it's making a one-way trip, so it's not like you can't like reuse it over and over again. It's not really meant for that. The ones that are made in America for American munitions are really, really expensive and only made by a handful of OEMs, right? So that's kind of the standard story, right, in our contractor world. So, but there's a lot of kind of upstart manufacturers of these little turbines. They're not American, though, right? Germany has one that's called JetCat that's pretty popular with hobbyists. So people that are making, no kidding, like remote control airplanes with jet engines in them will use these things.
That's cool.
And then Czech Republic has one, and China has several. There's a whole new kind of industry forming around this that is kind of the coming together of advanced additive manufacturing techniques. So there's several startups out there that are like 3D printing little jet engines, which sounds amazing, but that's how advanced printing has gotten, right? You can print in basically like a shell and then the inner core. So 2 or 3 pieces, you're printing these things. So those are in development. But okay, so how do you control this little thing? So the little JetCat has its own proprietary kind of black box controller. You can't crack into it. You don't really know what it's doing. So on one hand, it's a simple thing, so it doesn't really need an advanced controller. On the other hand, it's a little jet engine. It's a complex dynamical system. If you want to control it in some other way, you have no ability to do it because it comes with this proprietary controller that's literally like embedded in it that you can't easily, or you're going to void all the warranties. Like you don't want to mess with it. So our proposal was that we could wrap our own controller around their proprietary controller. So we would control not just the jet engine, but we would control the system that was comprised of the jet engine plus proprietary controller.
Nice.
And then what the proprietary controller does is just sets a shaft speed. But if you actually want to control an aircraft based on thrust, so you want to know how much thrust is coming out of there. Well, it turns out that that's not a very simple thing. It's not linear. It's not a simple like, well, the shaft speed is this, or the exhaust gas temperature is this, therefore the thrust is this. And we actually proved that pretty decisively in our project. So we put a 100 Newton JetCat, which is a small, I think it's the smallest that they make. We put it on a thrust table, so actually had a load cell that could measure how much thrust it was producing. We measured all the signals that we could, so like voltage to the fuel flow, pump to the fuel pump, shaft speed, and then there's an internal thermocouple for exhaust gas temperature, pretty standard. But we put our own thermocouple on the outside to measure the skin of the jet engine. The reason we did that is because we figured out that was actually pretty crucial to the machine learning algorithm to accurately predict thrust. So that rig became our truth data, right? So a machine learning algorithm, you need to train it somehow, or at least the training that we care about, the applications that we care about, we need to train on truth data. So once we had this thing set up in this rig, we were able to collect, no kidding, truth data and train our algorithm. So we did a handful of engine runs. Like I said, at first we didn't have that extra thermocouple, so our results for predicting thrust were good in one regime but bad on another, like off by 10%. So, but for no good reason, right? So we added that thermocouple on the skin of the outer skin around the combustion chamber, and that correlated to the change in thrust. So basically what that means is as the engine was heating up, the amount of thrust that it was producing changed on an order of 10%, which is crazy. And it was not a known or predicted thing until we measured it. So anyway, we were able to collect data and then train our algorithm. And once the algorithm was trained, it can say for a given requested shaft speed, it can say this is what the thrust is going to be, and it can predict it, within 2%, like 1.8% error, so very accurately. I mean, that all sounds kind of academic. So what's really cool though is that our machine learning algorithm was able to learn the data points from, I think it's probably a total of 10 minutes of engine runs of like kind of randomly varying and up and down stepping the engine around. It's a total of like 400 data points. That's all it took for it to be able to predict the thrust, 400 data points. And we were able to run those data points through the algorithm that was running on a Raspberry Pi, so like a $50 little microcontroller. And it trained the neural network in 2.1 milliseconds. And then once it's trained, cool. it can create a prediction at like 200,000 hertz on a Raspberry Pi. So it's able to evaluate its model and create a prediction of what should be happening at an incredibly high rate on an embedded type, edge type device like a Raspberry Pi.
And and you're not really changing the size or the power consumption of the end product, right? Because you're not adding a lot of hardware to it. Is that accurate?
That is accurate. And our ideal situation is there's already a microcontroller that we have access to. And just like you said, we push a software update, a firmware update to something, and all of a sudden it has a game-changing capability, as opposed to, we got to strap a whole new thing on this thing. Yeah. In the case of this little jet engine in the phase 1, so phase 1 is supposed to be kind of a proof of concept. So it is kind of a minimal effort. So for the phase 2, like what we really wanted to get to, what we really do want to get to is an integrated power propulsion thermal management system. So power propulsion thermal, PPT, it's a big problem for like, 6th gen plus aircraft. So higher, faster. So you got skin heating going on. Higher is good for thermal because it's cold up there. But your motors that are generating unbelievable amounts of thrust to get you that fast, they actually don't use that much fuel, especially as engines get more and more efficient with each generation. So fuel is a typical method of shedding heat, right? You actually circulate the fuel and heat it up. It's actually good for the fuel as well, right? It changes the chemical, it elevates the chemical state, and it burns better when it's hot. And now you've kicked that heat out the back. But the less fuel flow you have, the less capability you have. And now the faster you go, the more you're heating up. So you can see that these are all big problems, and they all are related, right? Because the motors are generating heat. And oh, by the way, it's power propulsion thermal. So the power piece is the electrical generation piece. So electrical generation creates heat. Sensors require power, sometimes a lot of power, depending on what they're doing. So all these things are interrelated. What's crazy is that the traditional solution is to cobble together these subcontractor systems. One company makes the motor with its own controller. One company makes the electrical power distribution system. One company makes the sensor. It's all disparate, so it has to be cobbled together. Yeah. So our overarching premise is that if you have a management system that has a machine learning algorithm, as its key capability, you can now learn those complex interactions. You don't necessarily have to turn around and control, but the least you can do is start to understand what the optimum performance is. You can establish a baseline of performance, and then you can start to alert to deviations from the baseline. So that's the going in premise for our phase 2. Eventually, big picture, we'd love to be paired with an aircraft OEM, a big integrator that is bringing these systems together. So in the meantime, we're starting small. So just to prove that we can up the complexity, we are creating a hybrid powertrain for like a hybrid UAS. So hybrid drones are definitely a thing. They're an up and coming, growing market. It has its own challenges in and of itself, believe it or not. And this is another great example of technology that translates from the drone space to the flying taxi, urban air mobility space, because they certainly have interest in hybrid powertrains. So the amount of power generation and handling that immense power load for aircraft electric motors is a huge challenge, and then kind of balancing everything out between your batteries, the power distribution, your gas engine, your heavy fuel engine, be that a turbine or a reciprocating engine, and having that all operate in unison is a huge challenge. So we're going to prove that out on a small scale first. Go ahead.
Nice. And not to dive too deep down this rabbit hole, but I imagine that we're leveraging the gas powered motor, whichever that one is, to kind of get up to altitude. And then once we're up at altitude and we're just kind of cruising, that's where we're using the electric, or is it the other way around, or is it varied?
Yeah. So what we're creating for the project is a generic power propulsion thermal system that does not have an aircraft attached. It just has all the pieces. Okay. But what I imagine it being is a high-speed VTOL aircraft. So it's going to have 4 to 6 lifting motors that are electric. So it allows it to vertical takeoff. And then it has a jet engine for horizontal propulsion. And it can also aid in the lifting propulsion. But you have a jet engine for your electrical power, and obviously you're pulling the generator's pulling kinetic energy off the jet engine for power generation. But you're primarily using your electric, like you have a big electric draw at takeoff and landing. And then once you're up at altitude, you have, depending on what kind of sensors you're using, right, you have electric draw. Then you also have a thermal loop potentially for keeping the batteries at an optimum temperature at altitude. So that's all going to be baked into what we're looking at. So the end product there is going to be a very small companion computer, so like a Raspberry Pi style plug into a power distribution board that will initially just model subsystems and the overall system and then report back. And really what the Air Force is interested in is more of that kind of health and status for like fleet management, which, dude, there's just so many offshoots to this, right? Like just the idea of being able to accurately predict the remaining useful life of one of these kind of attritable little jet engines is really compelling. But then think about the market for being able to accurately predict battery remaining useful life. So there's a lot of people looking at that right now. A lot of different solutions, a lot of different algorithms out there. But if you already have a smart battery, which usually if someone says smart, that means there's a microcontroller somewhere. Usually what that microcontroller does is collect data, sometimes to kind of show some sort of state of charge of a battery. But then you ask the manufacturer, like, what are you doing with the data? It's like, oh, no, we haven't figured that out yet, or we're not doing anything. We're just collecting the data. It's smart. We collect the data. It's like, well, what are you doing with the data, right? So yeah, there's a big offshoot opportunity out of this for both the microturbine, which that's more of like a DoD kind of niche thing potentially. But if the battery piece and health and status of the battery, if that pans out, we've done some simulation testing where it's incredibly accurate that we're able to, on very little data, predict the useful life of a battery pack. and that has its own market. So
yeah. Well, the one question I had was for the resolution type stuff, or the OCR type, like target recognition type stuff that you guys have been working on. How does that work? Is it like an OCR that we would find off the shelf, or is it doing something wildly different because it's using that, like, what is it, the artificial neural network and all that?
I'm not sure I'm following. So we haven't done too much work with auto target recognition.
I guess I was gotcha. With the I thought you said one of the PhDs, I think it was Dan, did optics.
Yes.
And recognizing products. Is that what it was doing, or what was he working in optics with?
Yeah, that's just his background. And I bug him every now and then to bring that side of his experience and knowledge to the company, but we just don't have the time. But rest assured that our technology roadmap is very, very long and deep. I guess I should say, so to speak, on that whole thing. So
yeah.
but it's just a matter of time and effort, and that's a huge challenge for any entrepreneur out there. That's been a huge challenge for me. Just full of incredible opportunity and excitement for the possibilities, and then you just shotgun your efforts everywhere, and that is not what is needed to actually create a definitive product that is enables you to climb, lip crawl out of the valley of death and actually get on a trajectory. So the combining the optics knowledge that Dan has and the kind of the state of the art for image recognition, I think we have a play there. Well, I know we do, because Dan says we do, and I actually have a second co-founder. I haven't mentioned him at all. His name's Andrew. He's also a PhD in physics. He has his own research company that's done work for DARPA. We have considered pitching some kind of ground level kind of in pixel processing, it's called, if you've ever heard of such a thing, where there's actually neural networks like in the electronics beneath each individual pixel that's pre-processing. Yeah,
that's wild.
So we think we have a play like on that level, where you're actually instantiating the neural network in the electronics themselves. It's really super fast when you do that, like ridiculously fast.
Yeah. Well, I imagine, I know, you flew F-16, so you probably remember the pod, the sniper pod, where it's an HD pod. It's actually a good pod, but it goes through, like, I imagine, I don't know, but like a coax cable, like you used to use for cable TV. And then now it gets displayed on this like 4-inch monitor. That's just not good either. But then you go to the MQ-9 and it's this like amazing image that gets displayed. And now we talk about, hey, we have the ability to capture these optics and to see things really, really well. And now we can put like this processing in each pixel. And now you're like, that is where we get a tactical advantage, where if an adversary tries to do the concealment or anything like that, it's probably not going to be helpful for him, just because the tech has come so far. Well, I'll let you get going, but how can people contact you and reach out if they think they have some helpful stuff, or they want to kind of bring you on to work with them?
Yeah, I think the easiest way is to go to our website. So flyrescon.com, FLYRESCON.com, and go to the contact page. You can send me an email. I'm at my first name dot last name at flyrescon.com. So brian.gyovai, brian.gyovai at flyrescon.com. And I apologize for the Hungarian last name with the GY construct. It's actually pretty common in Hungary, but it throws people for a loop. But yep, so feel free to email me direct, or if you can't remember all that, go to the website, and be happy to take any questions.
Yeah, great. Well, I'll have your website and your email in the show notes. So if anybody wants to check it out, it'll be right there. You can click on it and message him directly if you want to reach out. If remember, everyone, I'm terrible at this. I'm supposed to say at the beginning, but I always remember by the end. Please like and subscribe and share the podcast so other people can hear about it, especially if you know some people in the innovation space that may be interested in this content. Send it their way. Let them know what we're working on so we can spread the word about the Kodiak Shack. Check out our website, kodiakshack.com, and then you can email us if you'd like to be on the show or learn more about us or our companies at info@kodiakshack.com. Steele, thanks for hanging out and making me smarter on some adaptive neural networks.
Yeah, Vader, it was fun, man. Thanks for having me.
Yeah, see you.
Yeah.